Hi Salman. So I worked out your answers for you. Oh, so okay, let's do this. You wanted to do number 4. Okay, so here it says, for goal seek, imagine that you can afford to pay £100 a month for a new car. You know the interest rate and want to find the price of the new car which you can afford. An Excel worksheet has been set up shown below, which of the statements are false. So you set up a formula for the payment in cell C5. No, that's true because that's what you've done here. You see, because the formula will look like that. Yeah. Okay. You set up a formula for the price in C12. You set up the formula for the price in C12, which should look like that. Okay. Take the interest rate divided by 12, PMT formula, number of periods, and then your present value. What you would do is you would go into goal sequel solver, it's the same thing, and that's what it would look like. You would go set objective, which is that. You'd have to put -10, yeah? Key is you want to put the value of -10 because obviously what happens is you can only pay £100 a month, but that's got to show money going out. And then by changing variables that. So what you do is you click solve, and then that will solve it. And that will tell you, see, and that's your maximum. Okay. So based on that, we know that therefore A is actually true, and we know that B is not true because you don't put a formula in there. In goal seek, target cell is C5, that's true. In goal seek, the set to value is 100, that's true, so that one's false. Okay, as you can see in the answers. Yep. Okay, sorry. You set up, okay, by changing cell. Okay, sorry. Yeah, E is correct because that's the cell we changed. You set up the formula in cell C2, as I said. Yeah, that's false because, as we stated, the formula. Where's it close? Formula, as you can see in the cell here, formula is not there, is it? Because that's where we worked out the price. See, there's no formula there. The formula is in the equivalent, which is C5, which is why, therefore, this is false. This is true because we do change cell C2, as you saw in goal seek here. The solver. Yep. By changing cells, which is the equivalent of C2. Okay. You also wanted to understand what this is. So the rand, this function here, what this function does is it looks at a number between 0 and 1. So if I put it in, equals rand. This is it. Yeah. Okay. See, it looks at, if I just put it there, it will look at a number between 0 and 1. Okay. But then what happens if you times it by, so it's always looking at percentage essentially, that's like saying 61%, yeah. If I times it by 100, it will times that number, whatever it was showing, by 100. So it will show me numbers then between 1 and 100. Now if I minus it by 1, then it will show me numbers between 1 and 99. Okay. or 0 and 99, I should say. Yeah, so it will show me numbers between -1 and 99, because you can't show because it will be -100, yeah? Alright, I'm just double checking. So that was 4, 5. Yep. 4 and 5. And then you wanted to see 8. Okay, so here. The formula for this, yeah, is, I'll show you on Excel. The formula for this is, so that you take this. So firstly, it is this. Yeah, so your forecast, your actual from your last period. So it's that plus 1 minus A, which is the 0.4 there. Okay. Times by your forecast from your last period and your actual from this period, which is 230. Okay. As you can see, the answer there is 230. So all you would do is you would do this plus, open brackets, 1 minus that, times by that minus that, because it would essentially be 0.6 times 50 then, plus 200. Okay. So just do that again. It's that plus 1 minus 0.4 times by this minus this. Okay. And here it says this quarterly data represents the sale of champagne over the last 3 years. Which of the following modeling methods would you choose to forecast this data? So here you can see, so linear regression is looking, you want to forecast this data. So linear regression looks at linear relationships, which would be okay, but the key thing, moving averages over 2 periods is no, simple exponential smoothing is no, the multiplicative decomposition is used here. Do you want to know why? It's because that's to deal with seasonal trends. Linear regression, all these other ones would not be able to deal with the seasonal trends. Multiplicative decomposition is the method you would use to deal with seasonal trends. And when you look at a graph to see seasonal trends, it would be, you can see here in 4, it goes up massively, significantly from the others. And then 8, the same. And then 12 again. So you can see it's very seasonal, and that's what they're trying to show you. And that's why it's multiplicative decomposition, because of the seasonal nature of it. That's why linear regression, all the others don't deal with the seasonal, don't deal as well with seasonal variations. You can use them, but not. And also, you would want, you wouldn't have your moving average over 2 periods, it would be longer. Okay, so you wanted to know 13. Okay, so this says a manufacturer who wishes to produce products X and Y. The amount of raw material is limited to 500 kilograms. So that's telling you that you have a limit on raw material. Okay, so here there's a limit on this, and there's a limit on 4,000. So whatever you do, whenever you see that, you would expect, in this case, for each one of these then, you would always see it. It's always whenever there's a limit on something and you've got multiple products, you'd have product X and product Y. I'm just going to delete these because they're really annoying. Okay, and then you would have raw material. Yeah. And then just floor space or whatever it was. And it would be written like this. It would always be X, plus Y less than 500, and then X plus Y less than 4,000. and whatever it would be whatever, however much x, or x, say, let x say in this case x uses 1 and y uses 2, and then x uses 3 and y minus. You would always expect to see it written like that. That's how much x uses of floor space, or whatever we're looking at, of the raw material in this case. X uses 1, y uses 2 per unit, and of the floor space x uses 3 and y uses 4. So what happens there, what that's saying is for every unit of x produced, you use 3 of floor space, and every part of y you produce, you use 4. So you would add those two together, and then eventually the more and more you produce, you get the limit of 4,000. But the whole point is you always have to see this less than, it will be less than or equal to, so you'll see that little mark underneath it, the little slash underneath the arrow, but it should always be a less than sign. Okay, so it should be less than 500 or equal to 500. So it'll be less than equal to 500 and less than equal to 4,000. So knowing that, it cannot be any of those because it's greater than 0, and that doesn't make sense. Less than 30, well, there's no constraint there that's 30, it's 500 or 4,000. Okay, so it could be this based on what I've told you, which is 500, but x doesn't use 30 of the raw material because 500 is a constraint for raw material. So it would have to be 2 or 5 here, and then the same goes here. 2 or 5 less than 4,000 doesn't make sense because the raw material is 2 and 5, and then the floor space is 30 and 60, so it can't be less. So it can only be this. And what that's saying is every unit of raw material, every unit of x for raw material uses 2, and every unit of y uses 5. And add those two together, it has to be less than 500 or equal to 500. Okay. Because you've only got 500 of raw material. So that's what that is saying. It's literally that simple. That's what that's saying. So 2 of x, 5 of y must be less than 500. 30 of x, 60 of y must be less than 4,000. Should be less than or equal to, correct, if it's truly correct, but okay, so this one's relatively simple. This is what we did last time. So you can see here, these are all your VLOOKUPs here. Yeah, you're looking in between. So this is saying the lower bound. So you're looking at, so this is saying anything between 0.2 and 0.35 probability is 2 customers. Everything between 0.35 and 0.54 is 3, so on and so forth. So we've got 0.7650. You see 0.76 there, but that's 0.7605 is bigger than that. So you just go to this number here. So you just look at that, and you go along here, and you look at where it could sit in between here. And obviously 0.7605 is bigger than that, but less than that. So it's bigger than that, less than that. So it can't be there. It's bigger than that, so but less than that. So it must be here. So it must be 5 customers. Okay. So you just look at that, look along here, say, okay, it's bigger than that. Okay, so it goes in here, but less than that, so it must be there. Okay. So 14, 19. Okay, so the following spreadsheet set up to determine the maximum price of a computer system which a business can afford with a regular payment of £200. Okay, cell A2 represents the annual interest, and cell B2 represents the term month of the loan. Okay, so term month of the loan. Alright, which one of the following statements? If you use goal C to determine the maximum price, the set cell is C2. Use goal C. No, the set cell is not C2. Okay, because you have to change cell C2. Yeah, we're changing cell C2 to get to the price, to the maximum price that we can choose. Yeah, so that's wrong, and then that's exactly the same. So that's wrong as well. Solver is a quicker way to determine the maximum price. That's not true because they're the same thing. Solver and goal seeker are the same thing. The maximum price is 10,320, or if we use solver we can find that out. So let's show you how you would do it, because now we're going to use solver. It would be exactly the same as what we just did. We would just change that to 100. So what we would do, you'd set your objective, which is here, because you're going to set that to 200. You're saying the maximum you can afford is 200. Yeah. And you're going to change this one. So you solve it. Okay, so the price is not 10,200, 320. It's 8,271. Okay, because remember we put that PMT formula when equals PMT. It's an annual interest rate, so you divide it by 12. You put 48 in there, and then the present value is that. But obviously we don't know that at the time. Okay. So obviously we put the minus 200 in there, because remember it's money going out, and you set your objective, which is that. And we want that to be minus 200 because that's the most we can pay. And then what's the price that we can get? You change that. Okay, solve. Okay, simple. So we know if you use goal seeker to determine the maximum price by changing cell is C2, as we said. You want to change that to find out what price you get. Okay. So this one, this is a sensitivity report. The sensitivity report that tells you, this gives you all the maximum. This tells you all the different aspects of the limiting factors that you can use. It tells you, so it gives you a report on the limiting factors that you have analyzed. You know, we've done this a few times in previous tutorials. So here, when they say the objective coefficient, this means what you're trying to maximize. This is your contribution. Your allowable increase is how much you can actually increase this by. Allowable decrease is how much you can decrease this by. Your final value is how much you're making of something. Yeah. And the reduced cost is how much you can go down by. Okay. And these are your constraints. These are the adjustable cells. So these are what you're trying to maximize. Yeah, how much you're producing of something. These are the constraints that you work with. Yeah. The only constraint, the only time something's actually a real constraint is if it's got a shadow price. If there's a price here, it shows you then therefore it's a constraint. And that tells you how much of a constraint it has. This is how much you can increase it by without it becoming, you know, non-profitable based on the other aspects of the information that you have, okay? And then your allowable decrease is that. I mean, that's just how much you can reduce something by. Okay, so which of the following is true? Hot tomato sauce is not profitable. Well, that's not true. Basically, that's not true, because if it was, then it wouldn't have a 0.1 coefficient. Because that's its contribution, so it must be making a profit. Okay, so if it's all, as long as that's positive, then it must be making a profit. You would buy 5,000 more bottles at any price up to 20. Well, you wouldn't, because your allowable increase is 2,500. So you would only buy 2,500 at a shadow price of 20p. Yeah. All of the resources are scarce. As I told you, only things with the shadow price are scarce, so tomatoes used are not a scarce resource. If the profit on hot tomato sauce reduced by 10p per bottle, it would be worth making. Well, no, because it was, if the profit on reduced by 10p per bottle, then it would be 0, so it wouldn't even be worth considering. So therefore, if diet tomato sauce was 9p per bottle, the best solution would be different. Well, no, because the reduced cost, it would have to be, if diet tomato sauce was 9p per bottle, it would be different, yes, because then what would happen is that would be 0.09, so you would have that as 0.09, and that would be 0.1, so that would be more profitable to make. So you would actually see that this would be produced more than the diet one, because obviously the contribution would be higher. Yeah, this contribution, this part would be higher than this, because that would be 0.09. Yeah, so therefore, yes, that's correct. Okay. And then, so 2022. Okay, so this is the case where, let's go to the internet for this one. So we've got a normal distribution. Key thing with normal distributions is you see this curve here. So they're asking you how many things are outside. So within 2 standard deviations, yeah? Every 95% of things is within 2 standard deviations. So when they ask you, 95% of your data, is within 2 standard deviations. So you would take that 2, so if it's 90%, if they're asking you 5% of the values will be more than how far away from the mean. So they would be more than 2 times away from the mean, because 95% of your standard deviation is within, 95% of standard deviation is within 2 standard deviations of your mean. And if you've got 2.5 standard deviation, you would just take 2.5 times it by 2. So 95% of your data is within 5 standard deviations, is within 5 standard deviations away from your mean. Yeah. Okay. Because you would take that 2 there and times that by that. So anything above that, 5%, will be beyond your mean, so it'll be more than 5. Yeah. So the answer is B. If the data is normally distributed, 5% standard 5% of values will be more than how far away from your standard deviation. So you just take that, whatever standard deviation it is, times it by 2, in the case of 95%, and your answer would be 5. If it was a 99%, then you would times it by, I think, around 2.6 something. Okay. So here it's saying a solution matrix with the options is shown below based on the table which option should be adopted. So it's asking you which is the best option. So you just literally, and it's giving you the answer A or B. So if I was to say it's A, B, and C, and you got 10, 6, 6. You go 8, 5, and 9. You go 6, 7, and 8. It's literally just choosing which one's the best. And as you can see, 22, 22, and 21. So you'd say A or B. Because A is 22, B is 22, C is 21. Literally that simple. And now on to the last question I believe you asked me to cover, which is 24. So if we go down here, let's go to the blank one, because it's better to explain this with the blank one. So here, with this normalized way, you can see you've been given these blank ones. So this must sum up to 30%, right? Because you've got 100% here, it's 20%, 50%, and then that's 30%. So you put 30% there. See if I can copy this into Excel. If I can't, then it's problematic. Yeah, perfect. So you can see there. So what we do then is you would do 0.3 here. So we've got 30%. Then we times that by 0.3. Right, because it has to be, because these are all times 0.3 as well. Actually, okay, because it's your utility score option 1 times 0.3, okay? So we know what the answers are there, great. So you just sum that up then. And then we can see the best options are either option 1 or option 3. Okay, so the answer is E. You see how that works? Utility score option 1 or option 3. Let's sum that up there. Option 1 or option 3. Okay, and you can see the answer is that option 1 or option 3, because you can see 5.0, 5.0, okay, because you choose it on the utility score, what makes people happy. Okay, that's the score. You don't care about this one, you care about the utility score, what makes people happy. Okay, so you want to choose whichever one has the highest utility scores, because that's what you care about. You don't care about this, you care about this.